Right, good day. Today we are going to deal with the topic Pythagoras Theorem. Right, in this exercise that we are going to do, we are going to use the idea which is known as Pythagoras Theorem. And this idea or this theorem, it was derived by a person by the name Pythagoras. Pythagoras is just the name of the person who started using this idea. Right. This Pythagoras theorem is an idea that is used to calculate the side of a triangle. So it means we are given two sides and we are to find one side only, right? Then this Pythagoras theorem again, it only works on a right angled triangle. In other words, if the triangle is not a right angled triangle, then Pythagoras theorem doesn't work. So it only works on a right angled triangle. So whenever you are to solve or to find a side on a right angle triangle, you must make sure that you know the triangle that you are dealing with. In this case, I mean you must know the sides, or you must know two sides of the triangle so that you'll be able to make use of the Pythagoras theorem. Right. Since the triangle is a right angle triangle, there is a formula that we use to find the other side. Right. Now, we have an example here. That's example number or question number 5 that we are going to deal with. So I'm going to define Pythagoras theorem, and we are going to make use of this idea to find the length of the side. Now, so looking at number 3, we are having, I think, as we can see, we are having about 3 diagrams in one. We've got triangle ADC, which is a right angle triangle. The right angle is at D here. And the symbol for a right angle is this one here on D, and this one on C, right? That's a right angle, which means it's 90 degrees. In other words, we say side AC is perpendicular to BC. When we say it's perpendicular, it means it's 90 degrees to BC. Or we are saying AC is 90 degrees to BC, or AC is perpendicular to BC, or we say AC is at right angle to BC, right? All those terms can be used. Then that's the symbol or the sign for 90 degrees, which is right angle. Then we also have got right angle triangle BDC, right? That's again another right angled what? Triangle that we have, right? Then from there, we also have what? Right angle triangle ABC. So those are the 3 triangles that are in one. So in this case, we must know exactly the triangle that we are dealing with whenever we are to solve what? A problem here. Right. By using the word solve, I'm just saying to find the length or to deal with the problem, right? Or to answer the question, right? Now, so here we are shown that we are dealing with a triangle ABC with angle. This is the symbol for angle at C here, right? This means an angle, right? It's 90 degrees, which means right angle. It's perpendicular, right? Then AB is equals to 13 centimeters and BC is equals to 5 centimeters. Then CD is perpendicular to AB, which means line CD is 90 degrees to AB, which means line CD is at right angle to AB. All that means the same thing. Perpendicular, right angle, 90 degrees, right? Then CD was 4.6. All that information is shown in the diagram. Then calculate the length of AC and AD. Right. So for us to find the length of AC, we must know the triangle that has got that side AC. Then we must also know that side, or we must define it, identify it. Is it hypotenuse? Is it the other two sides? Or is it a side that is adjacent to another side which is right angle to each other? Right? That information is very, very, very important. Now, so if you check on our diagram, this is side AC. AC is a side which is perpendicular to BC. Right? So these are the other two sides, which means AB, since it is opposite 90 degrees at C, it means AB is hypotenuse. And the hypotenuse is the longest side on a right angled triangle. It is the longest because it is opposite 90 degrees. So it is the longest side, right? Now, so if we are to make use of triangle ABC, will we be able to find AC? Right, check. We are told AB is 13. AB is 13. One side is in, the hypotenuse. That's the longest side. BC is also known. So we are given two sides, so we can easily calculate what BC. Now, let us look at another triangle. If we are to look at right angle triangle ADC, are we going to be able to find AC? AD, we don't know AD, right? DC is known. AC, that's the side that we want to find. So since we don't know AD, so we cannot find AC here. So we've got two unknown sides. So we can't find AC because we don't know the length AD, right? So we must know the other two sides so that we can find the other side. So which means we are going to make use of what? Triangle ABC. Check again, right angle triangle BDC. Right angle triangle BDC, we cannot make use of that right angle triangle to find AC because AC is not on triangle BDC. So we can't make use of that, right? Fine. So we are going to make use of triangle ABC. Now, what I've just done here is to extract that triangle and redraw it and put the information in so that it becomes clear when I am making use of Pythagoras theorem. So this is the right angle triangle that I've drawn here, right? So it's ABC. We are told AB is 13. Then we are to find AC. So I've just made use of a question mark here, right? Then CB. CB is what? Is known, is provided, or it's given, is 5 centimeters. So since we've got two sides that are known, then we can calculate AC, which is our third side. Now, what does Pythagoras theorem say about the right angle triangle and sides? Right, Pythagoras theorem says square of AB, right? The square of AB is equal to the sum of squares of the other two sides. What are these two other sides? The two other sides are the sides which are perpendicular to each other, which are 90 degrees to each other, which are right angle to each other, right? So these are the other two sides. So it's AB squared is equals to AC squared plus BC squared. Then I just substituted AB squared here. AB is what? 13 centimeters. So it's 13 squared is equals to AC squared plus BC squared. Then what is 13 squared? I'm going to simplify that and I'm substituting what? BC here, which is 5. Then let us now then put the squares here, which means we are looking at 13 squared. This thing here is not stable. right? So we have our square here. Then we also have another square here. Then we are also squaring here, right? Now, then we are going to simplify that part. 13 squared, 13 times 13 gives us what? That's 169. I'm squaring it. Or let me just transpose, right? I'm going to transpose 5 to come over this side. So it's 13 squared. Then let me transpose 5 squared. Then it becomes what? When I transpose it, it becomes negative 5 squared, which is now equals to AC squared, right? Then I'm going to enter the squares. Right. This one is squared. Five squared AC squared. Now, there are two methods here that we can deal with this problem. It's either we can use factorization or you simplify them and what? Find the value. Right, for the sake of maybe factorization that we dealt with in our previous topic, I'm going to factorize that. Then we deal with, and then we simplify it, right? Math is so funny. I'll use factorization because we are having difference of two squares here. 13 squared minus 2 squared. They are perfect squares, right? So I'm going to factorize that, right? Then we will come up with 13 minus 5. I've just distributed the numbers that I'm squaring, right? Then 13. Remember, the other bracket must be positive, must be having a positive number, right? This is equals to what? AC squared. Right, then 13 minus, let me put the square on AC. Then 13 minus 5, we come up with 8. That's 8. Then 13 plus 5, we're going to get 18, which is equals to AC squared. All right. Then 18 times 8, we are going to come up with, I'll enter the square there. Let me enter it first. It's moving well, so I'm entering something here. So AC. Then 18 multiplied by 8, that's 144. So 144 is equals to AC squared. Now, what is the number that we are going to square to come up with 144. You will find out that the number that we are squaring there, it's 12. So it means there that the number that we are squaring to come up with AC is equals to it's negative 12 or 12, right? But since we are talking about length, then it means we will then simply say AC is equals to 12 centimeters. That's what it means, right? That's our AC. Now, here I've just made use of difference of two squares, right? For the sake of fun of it, Now, but now we may not make use of factorization. We can just find what we can just make use of simplification, which means we will say 13 squared. That's 160, 169 that's 169 minus 25, right? Which will then be equals to 169 minus 25, it will be 144, right? Which is the same as this other number here. Which is also the same as equals to AC squared. Then from there we go back to find the values that we are squaring there, which is minus 12 or positive what? 12. That's square. So here I was just showing that we can use, since there's a difference of two squares, we can make use of factorization to simplify it, or we can simplify the squares, then we simplify it, then from there we'll then continue with what we have here, right? Now, so we have seen that our side is equals to be what? 12 centimeters. So you can then even check and go back and say 13 squared is 165. AC is 12 squared. It's 144 plus BC, which is 25. So 25 plus 144, it gives you 165, which is correct there, right? Then we move on to the second question. The second question, or the second part, it says find AD, right? We now know that AC is equals to what? Is equals to 12 here, right? So since it is equals to 12, allow me to write that information using what? Let me use a different color there so that we can easily identify the information, right? It's 12 centimeters. Oh, it's still black. No problem. No, let me use a different color. We calculated this and we found out that it's 12. Sorry, it's 12, right? So it's 12 there, right? So we now want to find what AD. AD is this one. AD. AD. Right, for us to find AD, we are going to make use of which triangle? We're going to make use of ADC. We're going to make use of triangle ADC. This is the second what? The second part. So I'm going to draw the triangle. After drawing that triangle, then I can then find the length. The reason why I'm drawing the triangle is for me not to be confused with the sides. So I must know the triangle that I am dealing with. But if you are okay with the triangle on other triangles, then it's not a problem, right? But if you cannot see your triangle clearly, then just extract it, draw it, then uh, um, find the side that you are supposed to find, right? Right, then there is my triangle. It's just a sketch diagram. It guides me. Right, so it's a right angle triangle here. And we know our A. That's A. Then we have D here. And we are having C. Right, in this case now, our C is no longer right angle, right? Our right angle is at D, right? This time we are dealing with triangle ADC. Let me go back. Let us go back to the diagram so that we can actually see what I'm talking about, right? So this is the triangle. This is A to D. Our right angle is at D. And AC this time is now what? It's now the hypotenuse, which means it is the longest side. All right. So let us go back to our color here. Then let us now solve it. So it means in this case now, since our AC is now the hypotenuse, it means according to Pythagoras theorem, we are going to deal with what? We are going to deal with using Pythagoras theorem. Pythagoras theorem says the longest side or the hypotenuse, the side which is opposite to right angle or opposite to 90 degrees is equals to be the what? The longest. So AC, it now means AC squared there. Remember, it is our longest side now. AC squared is equals to, then we have AD squared equals to, so not equals to, but plus, sorry for that, plus DC squared. Then from there, I'll just substitute. Let me put the squares there before we move on to the next part. So here, we are having our square here. This is the definition of Pythagoras theorem on a right-angled triangle, right? Then from there, we move on to the second part. I'm going to substitute now. AC is what? 12 squared, which is equals to, then we have AD, that's what we are going to find, then plus DC. DC, remember it is 4.6. This is let me show, this is D what? DC, so it's 4.6 there. So we substitute 4.6. 4.6. We also square that one. So it's squared, and squared. Now, then I'm going to transpose 4.6 to go to the left-hand side. Right. I'll transpose this to go to this side, which means it is going to be, that's 12 squared minus 4.6 squared, which is equals to 18. Again, we are dealing with squares. All right. Then, if you calculate, this time I'm not going to use factorization, right? I'm just going to make use of what? Simplification. 12 times 12, we come up with 144. 144. Then we subtract 4.6. 4.6 squared from my calculator. It shows me 4 by 4, that's 21.16, which is equals to AD squared. Then 144 minus 12.16, we have 122.86. That's 122.84, which is equals to AD squared. Now, I'm going to use the squared sign, which means I'll then simply say now the squared sign, for the sake of explanation, let me copy what I have there. Then I am going to put the squared sign, but I'm now going to start with AD now, right? Which means AD squared is equals to 122.84, right? This is square, so I'm going to make use of the radical sign. All right, that's, I'm putting square roots both sides, right? Then I'm also putting a square root here on 140, 122 right? So whenever I'm putting a square root sign, I must make sure that I put plus or minus outside, right? So I'm going to put that plus or minus because there are always two answers that I can come up with, right? So it means here my answers are going to be, one of the answers is what? Plus, and the other one is what? Negative. It could be positive and the other one could be negative, right? Which means my AD is now equals to, then we say the square root of 122.84. Did I calculate my number correctly? Squared minus 4.6 squared as well. Yes, I get 122.86 then. Square root of 122. I'm going to come up with, that's 11.08, right? The number goes on to say 33208. Then I'm just going to estimate it to 2 decimal places, which means it is equals to 11.08. This is to 2 decimal places, centimeters. So that's my solution. Then from there, we move on to the next question. Then our next question, if we can check, it says here, calculate the area of triangle ADC. ADC. Now, for us to find the area, right, allow me here to put a line here, then I will solve the other problem so that all my work will be on one page. All right. Now, but whenever you are solving problem, don't divide your page into two. All right. Just make use of your page. Just write one problem on one page as you go. Right. So here I'm going to solve 5.2. I'm going to answer 5.2. Right. How do we find the area of a triangle? Right. By definition, area of a triangle is equals to, normally we make use of symbols to say it's half. So 1/2, I'll write that fraction, right? 1/2 times base side times height. Sorry. Right. So in this case, we are saying it's half base times height. When we are talking about height here, we are simply saying this is one of the side which is perpendicular to the other side of the triangle, right? So this is a height of the triangle, right? And there is one side that we are going to refer to as the base, right? So the base and height, these are the sides that are perpendicular to each other, or these are the sides that are right angle to each other, or these are the sides that are 90 degrees to each other. So the base and the height are the sides that are perpendicular to each other. So if we check here now, on our triangle, which sides are perpendicular to each other? Which sides are right angle to each other? Remember, it's triangle what? A, D, C. So the sides that are perpendicular to each other, it's what? It's AD and what? DC. These are the sides that are perpendicular to each other. So one of these sides is the base and the other one is the height. They are perpendicular to each other. So one of the sides is base, the other one is the height, which means we are now going to say it's half there times, let me now say my base is what? AD. My AD is 11. It's AD. I just want to identify them or to know them. Times height. My height is what? My height is DC, right? Then from there, let me enter my half. Remember, it's a half times right, then equals to, again, that half. I'm now substituting, which is half. Half, remember, is the same as 0.5, right? You can as well make use of that. But for the sake of the formula, we have to make use of the fractions the way they are. And multiplication there, remember, we can make use of the dot multiplication. AD, which is 11, we found it to be 11.8. Then multiplied by 4.6. Right? Then from there, it now then means that if you check, if we use by using a calculator, we are saying half multiplied by 11.08 multiplied by 4.6. Our area is 25.484 centimeter. Since it is area, we multiplied two dimensions. Since we multiplied two dimensions, it means our symbol, the symbol that we will put there to show that it's area, or to show that we multiplied two sides, is by putting square here on the unit. So it means our area now is equals to 25.484 centimeter squared. So that's how we use Pythagoras theorem. Remember, I said Pythagoras theorem only works on a right-angled triangle, and it only works if we are given two sides. If we know two sides, then we calculate the third side. That's it.